Let's take a look now at section 2.2 and talk about circles. So let's begin with a definition. What is a circle? A circle is the collection of points that are a uniform distance, which is called the radius, away from a common point, which we call the center. Essentially, to find a circle, you pick a point and call that the center. H and K are often used as the symbols for the coordinates of that point. 2, 5, 1, 3. H, K is typically given as the designation for the center of a circle. Now you pick a distance, 1 inch, 2 feet, 40 miles, whatever that distance might be. Now find every point that is that many units, that is that distance away from the center, in every direction. That distance that you picked is called the radius of the circle, usually given by the symbol R. If you find every point that is R units away from the point HK, that gives you a circle. Okay? The equation to a circle can be found using the distance formula. So recall, the distance formula, given 2 points, x1, y1, and x2, y2, the distance between them is given by d equals the square root of the difference in the x values, x1 minus x2 quantity squared, plus y1 minus y2 quantity squared. This is the distance formula, and it comes from the Pythagorean theorem. All right? Now, this is a formula that we see in pre-algebra, and we're going to use this to describe the circle, not with words, but with an equation. Because after all, here we're saying we want all the points that are equidistant from this common point, H and K. So what I want is every point, and here there's a bunch of points on the outer edge of my circle. I don't want to pick one in particular. I want this to be true for every point. So here I'm not going to pick a particular point. I'm just going to call X and Y a random point that's somewhere on the outer edge. I don't want to be specific. I just say X, Y is some point on the outer edge. So the circle is all of these points, X and Y, that have that distance R away from H and K. Okay, well, then the circle is all points X, Y that have a distance R from H, K. Well, here I have 2 points. I have my center, and I have some arbitrary point on the outer edge of the circle, which means here, if I subtract these two, that can go there. And if I subtract these two, that can go there. And since my distance is R, R can replace that value of D. So that means that I can describe my circle by saying R, that distance from the center to the outside, is equal to the distance between their X values, X minus H quantity squared, plus the difference in their Y values, which is Y minus K quantity squared. Just like that. Here, we usually try to avoid using square roots if we can avoid them, so we can square both sides to make things ever so slightly nicer. After all, square roots have to be positive. All right, you can't have a negative result as a result of a square root. So here it doesn't matter if we square this, we are not going to be getting rid of any negatives anyway. So if it doesn't affect anything, but it makes the numbers a little nicer to work with, why not? All right? So here we can write this as r squared is equal to x minus h squared plus y minus k squared. And this is what's called the center radius form of a circle. This is a formula that gives you the equation of a circle so long as you know the center and the radius. Hence the name, the center radius form of a circle. All right, so let's take a look at an example of this. In fact, a couple of examples from a few different points of view. First of all, let's say the following. Let's go ahead and give the equation of the following circle. And this is given as a graph. We're told, okay, here's a circle. It has a center right here. That's the point 2, 1. And then here's another point, 5, 1. All right. So here we know the center of the circle, 2, 1. Here the radius is simple enough to find because you're simply going over, if this is 2, 1, this is 5, 1, you're simply taking 3 steps to the right to get here. So the distance from here to here is going to be 3 units. So we know that our center, which in our symbols over here is designated by h and k, that's going to be given by 2, 1. So h is 2 and k is 1. And our radius, given by the symbol r, is the number 3. So here we can just pop all those numbers in. We can say, okay, 3 squared is equal to x minus h, in this case h is the number 2, squared, plus y minus k, in this case k is the number 1, squared. Here 3 squared is equal to 9, so we can just write this as 9 equals x minus 2 quantity squared plus y minus 1 quantity squared. And there we go. That's the equation whose solutions give you all the points on the edge of that circle. We can do one that's slightly more complicated. Same kind of problem. Give the equation of the circle. With endpoints of a diameter (7, 3) and 5, -1. All right. Whenever we say a diameter of a circle, that just means going all the way through the circle across the middle. So what this is saying is you have a circle. They don't draw it for us, but we can do that ourselves because we're given some points. 7, 3, 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3. 5, 1, 2, 3, 4, 5, down 1. Okay, so here, this is the diameter of a circle. The radius is halfway in between because the diameter means go all the way across the circle. So the radius would be halfway across the circle. So this is a visual of what we're looking at. We're told, okay, here's the point, 7, 3. Here's the point, 5, -1. And those are the endpoints of a line that goes all the way through the circle. So the radius would be right in the middle. Okay, so we're not told our radius, and we're not told our center either. Well, we kind of are, because after all, if this is the point that's halfway in between those, well, let's go ahead and find the point that's halfway in between them. Here, if this is halfway in between those two endpoints, then that means that the x value of this point is halfway in between those two x values. And the y value of this point is halfway in between those y values. So let's go ahead and do that. the x value that I want is going to be halfway in between the two x values of my two endpoints. When you want to find something that's halfway in between two extreme values, another name for that is the average. It's like on an exam. If you get a 90 on one exam and a 70 on another, what's halfway in between those? It's the average. The average of 70 and 90 is 80. Same thing here. We want to find the point that's right in between. We can do that by finding the average. And how do you find the average? Well, you add the two numbers and then divide by 2. So here that's going to be 7 plus 5. I'm adding the two x values, and then I'm going to divide by 2 to find my new x value. To find my y value, let me add the y values, 3 plus negative 1, and again divide by 2. The x value is just the average of my two x values. My y value is just the average of my two y values. So here my center is going to be given by 12 over 2, well that's just 6, and 2 over 2, and that's just 1. And there we go. So now we have our center. The next thing we need to do is find our radius. Well, once we know where our center is, finding the radius is just the distance from that center to the outside. So the radius is the distance from the center, which we found is 6, 1, to a point on the circle. Well, we have 2 points of our circle. I'm going to go ahead and just pick one. I'm going to pick 7, 3. It doesn't matter. It's any point on the circle. I'm just going to go ahead and choose one. Okay, so how do I find the distance between my center and my radius? Well, again, we have a formula for that. The given 2 points, the distance between them is, you're going to take the x values and subtract them, square it. Take the y values and subtract them, square it, add those, and then take the square root. That's called the distance formula. So let's see the distance formula. Incidentally, this right here, this is called the midpoint formula. So the distance formula is how you find the distance between 2 points. And that's going to be d is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. And I would just pop in those numbers. Here, d is going to equal to, take the difference in the x values, 7 minus 6, and square the whole thing, plus take the difference in the y values, 3 minus 1, and again, square the whole thing, which is going to be, well, let's see, 7 minus 6 is 1, square that is still 1, 3 minus 1 is 2, square 2 gives you 4, so that's going to be the square root of 1 plus 4. That's the square root of 5. So now we have our center and our radius. Okay, so we have our center is 6, 1. We have our radius, square root of 5. And now we're just about done. We just plug everything in because we know how to write the equation of a circle. The equation of a circle is going to be r squared equals x minus h squared plus y minus k squared. And now we know what all those numbers are. We know r is the square root of 5. So that's going to be the square root of 5 squared equals x minus, our h is the number 6 squared plus y minus k, which is the number 1 squared. Here, square root of 5 squared, well, that's just the number 5. So here we get 5 equals x minus 6 squared plus y minus 1 squared. And that's the equation of our circle. Now, we can go the other way around. Here, we start off with some details about a circle and end up with an equation. We can go the other way around. We can say, well, what if we start with the equation and then use that to graph the circle? So here's another example. Graph the equation. All right. We're going to graph the equation. Let's do x minus 3 squared plus y minus, let's make that a plus 4 squared is equal to 5. Let's make that 25. Keep the numbers nice for now. All right, so there's our equation. Remember, the equation of a circle is going to give you the center and the radius. All right? Here, this 25 is that r squared. So here, that 25 is r squared. Here, this x minus 3, that is your x minus h. And this y plus 4, that is your y minus k. So from there, I can find my r, my h, and my k. All right, so let's do that. Here, I know that r squared is going to equal to 25. Oh, so then r is equal to plus or minus the square root of 25. All right, take the square root of both sides, which I know the square root of 25 is just the number 5. Well, yeah, but 5 or negative 5. Remember, r is the radius of a circle. You can't have a negative radius. The radius of a circle is a distance from a center to the outside. There's no such thing as a negative distance. So here, since this must be a distance, it can't be negative. So that means it must be positive. So r must equal to 5. Again, radius cannot be negative. Okay, so now here, x minus 3 is going to be x minus h. Oh, well then your 3 must be your h. So here, this means that h is equal to 3. Notice right here the sign is wrong. Y minus k is y plus 4. Oh, that just means that I have a double negative here. I can write this as y minus a negative 4. Oh, okay, so then k must be a negative 4. One way to think about this is h is whatever number you can plug in here to make this 0. Oh, 3 minus 3 would be 0. So h must be the number 3. K is whatever number you could plug in here to make this 0. Oh, well, negative 4 plus 4 is 0. Oh, so then k must be negative 4. You can think about it either way. What number do I plug in to make this 0? What number do I plug in to make this 0? Or you can think of it as, okay, what number am I subtracting from x? And here, what number am I subtracting from y? Oh, that was a double negative, so that's going to be a negative. Either one gets you your result. But now, that tells us that our center is going to be 3 comma negative 4. We have a center, we have a radius, and that's all we need. We can now graph. Our center is 3 comma negative 4, so we're going to take 3 steps to the right and 4 steps down. 3 comma negative 4. And now we're going to take a radius of 5, which means we're going to go 5 steps in every direction. We're going to go up 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5. Left, 1, 2, 3, 4, 5. And down, and here I'm out of paper, but it would go down 1, 2, 3, 4, 5. So then you would connect your dots to form your circle. And here, this should be a full circle. I just ran out of paper here. That's the edge of this of my paper. So there we go. Once you find your center and you find your radius, from your center, take however many steps you need to. You don't have to grab a ruler. Just go 5 steps up, 5 steps down, 5 steps left, 5 steps right, and connect your dots. Just like that. So go ahead and give that a try. Go ahead and graph x plus 1 quantity squared plus y minus 3 quantity squared is equal to 16. Okay. Go ahead and pause the video, find the center of the radius, and then plot a graph. Once you have your graph, go ahead and unpause and we'll go through it together. All right, so here we go. This constant here is our r squared. So r squared is equal to 16, which means r is equal to plus or minus the square root of 16, or in other words, r is equal to plus or minus 4. But again, since radius must be positive, that means it can't be negative 4. So it must be positive 4. r must be positive, so r must equal to 4. Here, our h is whatever number you plug in here to make this 0. Oh, that's negative 1. So here h is equal to negative 1. K is whatever number you would plug in here to make this 0. Oh, that would be a positive 3. 3 minus 3 would be 0. So that means that putting these together, our center is going to be negative 1 comma 3. And that's all you need. Once you have a center and a radius, you can graph any circle. All right, your center is negative 1 comma 3. So we're going to go to the left 1 and up 1, 2, 3. And now our radius is 4. So we're going to go down 1, 2, 3, 4. Right 1, 2, 3, 4. Left 1, 2, 3, 4. And up 1, 2, 3, 4. And then you connect your dots to form a circle. And that's the graph of that equation. As our last kind of example, sometimes the equation doesn't quite look like this. This is called the center radius form of a circle, and we like this one because it's easy to work with. It tells you the center, it tells you the radius, you just have to know where to look. However, some equations don't quite look like this. So let's consider the following example. We're going to go ahead and graph the equation. And this is going to look a little different. Let's try x squared plus y squared minus 10x plus 4y minus 20 equals to 0. Now that definitely doesn't look like what we had before. All right? We still recognize this as being a circle though. So how do we do that? Whenever you have x squared plus y squared as the biggest power terms in your expression, and their coefficients are the same, that's going to give you a circle. So here, this could be 5x squared plus 5y squared, or 10x squared plus 10y squared, or 7x squared plus 7y squared. As long as you don't have any powers bigger than 2, and as long as the x squared and the y squared both have the same coefficient, in this case they both have a 1 in front, then this will give you a circle. You say, okay, well, it might be a circle, but I still don't know how to graph it. I still don't know the center or the radius. Incidentally, this is called the general form of a circle. Whereas this one over here, it was called the center radius form of a circle. Sometimes the center radius form is also called the standard form. Standard because it's the standard one. It's the one we use the most often. So either of these is correct, either the center radius form or the standard form. That's the one we like. However, sometimes you'll get something that looks a little different. This is called the general form. And in order to graph this, the simplest thing to do is to rewrite this in this form. We want to write this in the center radius form, in the standard form. To do that, we're going to use a technique that we saw in the last chapter, and that's we're going to complete the square. Here, you're going to note that we have x squared minus 10x and y squared plus 4y. Those aren't perfect squares, but if I can complete their squares, I can factor them so that they look like this. And once they look like this, then I can figure out the center and the radius of my circle. So here we go. We're going to complete the square. The first thing we're going to do here is we're going to rewrite things a little differently here. We're going to go ahead and group all of our x terms together and all of our y terms together. Sometimes they're already like that, but other times they won't be. So here it'll be a little bit easier for us if we just rewrite things this way. X squared minus 10x. Let's put the x's together. I'm going to leave a little space here because I'm going to add some stuff in a moment. Here I'm going to have y squared plus 4y. And then let me leave my minus 20 over here. All right. So far nothing's changed. I still have all the terms. All I've done is I've left some spaces in here. All the x's together, the y's together. All right. So now, to complete my square here, we take the first two terms and bunch them together. Okay, well, we've already done that. In fact, we've done that twice. Once for the x's and once for the y's. The next thing we do is we factor out the lead coefficient. In this case, we don't have any number here. All right, so we would factor out the number 1, which won't really change anything. If there was a number here, we would factor it out, but most of the time you'll note that this will just be the number 1. All right, so now take this number, cut it in half, and then square it. So here that's going to be half of 10 is 5, or negative 5, and then square the negative 5 to give you a positive 25. But we're going to subtract 25 to balance that out. Plus 25 and minus 25 would cancel out if we let them. Likewise here. We take our 4, cut it in half. That gives us 2. And then when we square 2, we get a 4. But again, we're going to subtract 4 to balance things out. But now, even though these should cancel, and so should these, we're not going to let them. What we're going to do is we're going to regroup. We're going to keep the first 3 terms together. Take the last one and just kick it out of the parentheses. Since the coefficient here was a 1, it's not going to change as it leaves the parentheses. Same thing over here. We're going to keep the first 3 terms together. Y squared plus 4y plus 4. We're going to kick the minus 4 out. And then don't forget that minus 20 was already out there. So now we can simplify some stuff. Hey, look, that factors out. What 2 numbers multiply to give you 25 and add up to give you negative 10? Well, that's negative 5 and negative 5. So we can write this as x minus 5 times x minus 5, or more simply, x minus 5 squared. Hey, this right here, that can factor also. What 2 numbers multiply to give me 4 and add up to give me 4? Well, that's positive 2 and positive 2. So this will factor as y plus 2 times y plus 2, or more simply, y plus 2 squared. And notice these numbers are just regular numbers. Negative 25 minus 4 is negative 29. Negative 29 minus another 20 is negative 49. And now this looks almost exactly like what we want. We have something that involves an x being squared plus something that involves a y being squared equals to a number. Oh, well, that number's in the way. Okay, let's just move it over to the other side. So let's go ahead and add 49 to this side. Let's add 49 to that side. And now we have our equation written in the standard form, in the center radius form. So x minus 5 squared plus y plus 2 squared is equal to 49. And now we can graph that. Here, our center, 5 makes this first factor 0, and negative 2 makes this factor 0, like that. And our radius, well, that's going to be our square, the square of our radius, which means our radius must be the square root of that. There's 2 square roots of 49, positive 7 and negative 7, but again, radius can't be negative, so it must be positive 7. 5, negative 2, and then the positive square root of 49 gives us our radius. And that's it. We can graph this. Our center is 5 comma negative 2. 1, 2, 3, 4, 5 comma negative 2. And then our radius 7 tells us to go down 1, 2, 3, 4, 5, 6, 7. To go up 1, 2, 3, 4, 5, 6, 7. To go left 1, 2, 3, 4, 5, 6, 7. And to go right 1, 2, 3, 4, 5, 6, 7. You connect your dots, and that forms a circle. Yeah, be quiet. That's exactly what a circle looks like. Every circle's crooked. Everybody knows that. All right, so that gives us our graph. Go ahead and give this a try. Take an equation. It's going to be given in the general form. You're going to go ahead and graph it. And in order to do that, you're going to complete the square for the x terms and complete the square for the y terms to write it in the standard form, in the center radius form. Once you have the standard form, once you have the center radius form, then you can find your center, your radius, and get your graph. So I'm going to give that a try. Graph the equation. Let's try x squared plus y squared plus 12x minus 14y plus 84 is equal to 0. Go ahead and give that a try. And once you have your graph, go ahead and unpause the video and we'll go through it together. All right, so let's give that a try. We're going to complete the squares for both x and y. So let me rewrite this by bunching the x's together. Separately, let me bunch the y's together. That 84 is just going to stay out here. All right. Next, let me factor out the lead coefficients. Well, there's the number 1, so nothing's going to change. I can write the number 1 out here if I like, but that's not really going to do anything. So now to complete the square. Take this number, cut it in half, that's 6, and then square it. That's 36. Balance that out by subtracting 36. Same thing over here. Half of negative 14 is negative 7. Square negative 7 is positive 49. And then subtract 49 to balance that out. We can now rewrite this as x squared minus 12x plus 36. We're going to kick the negative 36 out. Same thing here. I can write this as y squared minus 14y plus 49. And again, that minus 49, we're going to kick that out. So the minus 36 and the minus 49, they're now outside these parentheses. And don't forget that 84 was already out there. And now things simplify. We can factor this. The two numbers that multiply to give me 36 and add up to give me negative 12 are negative 6 and negative 6. So I can write this as x minus 6 times x minus 6, or more simply, x minus 6 squared. The two numbers that multiply to give 49 and add up to give negative 14 are negative 7 and negative 7. So I can write this as y minus 7 times y minus 7, or more simply, y minus 7 squared. Here, if I take these two numbers and put them together, negative 36 minus 49, that's going to give me negative 85. But then if I add 84, that gives me just a negative 1. Go ahead and move that 1 over there. And now that looks just like what we want. We have this in our standard form. So x minus 6 squared plus y minus 7 squared is equal to 1. All right, so here, the positive square root of that number is my radius. So r is equal to the positive square root of 1, which is just the number 1. My center is going to be, the first coordinate is whatever makes this equal to 0. Well, that's the number 6. And my second coordinate is whatever makes this equal to 0. Well, that's the number 7. So now I have my center and my radius, which means I can create a graph. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Starting from our center, 6, 7. 1, 2, 3, 4, 5, 6. We're going to go up 1, 2, 3, 4, 5, 6, 7. There's our center, 6, 7. And then we're going to go one step in every direction. Our radius is 1, so we're going to go up 1, down 1, left 1, and right 1. And so here we're going to have a little tiny circle of radius 1 around our center. And there we go. So that's it for this section. This is a fairly short section. The main things to take away from here are we were practicing a little more on how to complete the square, but also we're reminding ourselves some basics of how graphing works. We're finding individual points and we're graphing. Circles aren't going to be a particularly central thing to this course, but we are going to use them from time to time as examples. The reason we want circles isn't because they're super important, but because they're really nice examples to a few things that we'll see later on. So that is it for the section. If anybody has any questions, comments, problems, please make a note of those. You can reach out to me next time we meet, or you can send me an email. I hope everyone has a nice day.